Okay, so we're starting with 8.5. We're getting into actual equations and solving equations. The focus will be on word problems, creating equations, solving them, isolating variables. We're going to be combining everything that we've looked at when it comes to exponential and logarithmic functions. The easiest way again is let's try some examples. There's nothing new in this section. You're just practicing the application of that which you learned in 8.1, 2, 3, and 4. So let's start with the first example. 2 to the power of x plus 2 minus 2 to the power of x is equal to 24. What we need to do is we need to obviously solve this equation, which means to isolate x. As it is, this is a very difficult equation to isolate because there's no way to combine these two. It's being subtracted. We cannot combine 2 to the power of x plus 2 with 2 to the power of x. They're not like terms. We cannot isolate x because there's more than one x. You can't convert it into logarithmic form because you have two different variables. What we then have to recognize is different rules that exist within exponents. So let's go over exponent laws quickly. A to the power of 2 multiplied by a to the power of 3. So you have a squared times a to the power of 3. This turns into a to the power of 2 plus 3. So working backwards, 2 to the power of x plus 2 must mean that this is 2 to the power of x, or sorry, not has to be, it can be done as 2 to the power of x multiplied by 2 to the power of 2. 2 to the power of x times 2 to the power of 2 would be 2 to the power of x plus 2. So what we've done is we've split it into two separate terms. The rest of it stays as 2 to the power of x is equal to 24. Now, again, we cannot simplify further, but we recognize there's a 2 to the power of x here and here, so we can factor it out. What are we left with here? 2 to the power of 2, I'm just going to write that as 4, minus 2 to the power of x. Once I factor that out, I'll be left with 1. Okay. And that's equal to 24. Whoa, I'm getting ahead of myself here. Is 24. So 2 to the power of x, this is 3. 24 divided by 3 is going to be 8. Now, in order to solve this, there's different things that we can do. We can turn this into log form because the exponent is the variable. We can convert to log form and calculate it that way. We can change this whole equation so that they both have the same base. Or we can take the log of both sides. There's 3 different ways to do this. I'm going to go ahead and I'll show you each one just so that you can see that the process, it will not give you a different answer, but in some cases, the different processes will give you easier answers. 2 to the power of x, let's start by changing the base. 2 to the power of x, I can write 8 as 2 to the power of 3. So 2 to the power of a number is equal to 2 to the power of 3. That number must then be 3. Straightforward. Let's do it again. 2 to the power of x is equal to 8. Let's isolate the x. So turn it into log form. X is equal to log base 2 of 8. What does this mean? 2 to the power of what number will give me 8? Remember, this is going to be 3. Alternatively, if you try to solve this using a calculator, log base 2 of 8, you would just get 3. If you do not have a calculator that can adjust the bases for logs, where the only option you have is just to press log, you can't change what the base is, meaning the base is always 10, we can use something called the change of base formula. So we're going to apply that here. The change of base formula would be, the change of base formula, what it does is it rewrites your expression so that it's base 10 instead of base 2, for example. So it would be log of the argument, so log 8, base 10, divided by log of the base, so log 2. So log 8 divided by log 2 is the same thing as log of base 2, log of 8 with the base 2, and this will also give you x is equal to 3. The third method, this is a new method. This is where we are going to use the different properties that we have, different characteristics, different laws that we've learned about logarithms in order to solve this. So what I have right now is 2 to the power of x is equal to 8. Well, if 2 to the power of x is the same number as 8, then log of 2 to the power of x should equal log of 8. because I'm doing the same thing, right? If 2 to the power of x is the same number as 8, then log of this number should equal log of 8. So I have set this up using my laws of logarithm, the power law. That means I can bring the x down and write this as x log 2 equals log 8. And then I can take log 2 to the other side. X is equal to log 8 divided by log 2. Same thing we did here, right? Same process as here. Then you'd go ahead and plug that into your calculator and you'd find that x is equal to 3. 3 different methods. This method will not always be available, right? Because if the answer was meant to be a decimal number, it's going to be very hard to convert a base into a decimal exponent. So for example, if this was 9, to turn 9 into 2 to the power of something is going to be very, very difficult because it's going to be 3 point something, but is it 3.1, 3.14? It's very difficult to get. So this is not always going to be available. These two methods will always work. Okay, let's try another example. Okay, we're going to look at example 3 in the textbook. It's a word problem. So let's summarize what we know and use it to come up with an equation. An investment of $2,500 grows at a rate of 4.8% per year, compounded annually. How long will it take for the investment to be worth $4,000? Recall that the formula for compound interest is given as A equals P multiplied by 1 plus I to the power of N. In this case, A, we know the value at the end of the interest. We want it to be 4,000. The value today, meaning how much is being invested, is 2,500. The interest rate that is given is 4.8%, which turns into 0.048. So we are given everything in the equation. Let's set it up. 4,000 equals 2,500 multiplied by 1.048 to the power of n, because that would be 1 plus 0.048, and we would end up with that equation. The question is asking us to figure out how long will it take for this $2,500 to grow to be 4,000, meaning they want us to solve for n. Let's go through the process. Let's take 2,500 to the other side and divide, right? The 200s will cancel out. 40 and 25 would be 8 over 5 if we divide both of them by 5. And that's equal to 1.048 to the power of n. Clearly, this is one of those situations where I cannot represent. This is 1.6. Cannot represent this as 1.048 to the power of something. So instead, what we're going to do is take the log of both sides. So we'd have log of 1.6 is equal to log of 1.048 to the power of n. And then once we bring n down, log of 1.6 is equal to n log 1.048. And to finally isolate n, we'll have log of 1.6 divided by log of 1.048. Both of these are base 10. So we just plug that in your calculator, and the answer that you get will be 10.025. So approximately after 10 years, the $2,500 will grow to be 4,000. Example 3, we have an equation, we need to solve it, meaning we need to solve for x. We have 2 to the power of x plus 1 equals 3 to the power of x minus 1. Just like in example 1, we could split these two so that it becomes 2 to the power of x and 2 to the power of 1 and 3 to the power of x and then 3 to the power of negative 1 and see if that will work. However, in this case, we already have two different terms equal to each other. There's not multiple terms on each side, there's just one term. So, and what we need to do is we need to get x out of the exponent. Remembering the power law, if this was log of 2 to the power of x plus 1, I can just take that exponent x plus 1 and bring it down. Meaning if this is log of 2 to the power of x plus 1, I can now automatically just bring this down and make it x plus 1 times log of 2. And this I can do log of 3 multiplied by x plus 1 because I would, x minus 1 that I've brought down on the other side. And now at this point, we need to go through and solve whatever we can. So let's expand both sides. So we would have x log 2, right? Because log 2 times x, then log 2 times 1 plus log 2 is equal to, here we'll have x log 3 minus log 3. This times x and then this times negative 1. Now again, it looks complicated, but remember your process. You want to isolate x. What that means is I want to bring my x's to one side and move everything else to the other side. So here I'll have x log 2 minus x log 3, and that's equal to negative log 2 minus log of 3. From these two, I can factor out an x. I'm left with log 2 minus log 3 is equal to negative log 2 minus log 3. In order to isolate x now, we would take this whole term to the other side and divide it. So I have negative log 2 minus log 3 over log 2 minus log 3. Okay, and then for this one, you'd plug it into your calculator, and the value that we would get is approximately 4.419, because the original question does say to solve it to 3 decimal places. Okay, it's going to be important just to remember the rules as they are. If you have gone over 8.3 and then in the summary section, there's those 3 rules to remember. In 8.4, there's the 3 laws to remember. After that, it's just about being able to manipulate your equations effectively in order to isolate the variable using the laws available.